This tutorial shows the implementation of secant method, which is similar to Newton's method, Newton-Raphson method, but the derivative of the function may not be available, and in that case the slope, line slope using 2 points is used, which is the secant of a curve, is used to estimate the derivative of the function. And within secant method, the one we are applying is also called a modified secant method, because we don't really take 2 points, we take 1 point and perturb it a little bit by some delta amount to get a second point. So in your manual, there's an equation written where this the function is divided by its derivative, which is the difference between two very close points divided by the distance between them, and that delta value is set by the user. It could be 0.5, it could be 100, depending upon what kind of jumps you want to make and how you want to define this little derivative of the function. So we will take the Newton-Raphson code and just make this minor change, and we will get a new function. So take the Newton-Raphson function and then save as, and call this secant, and make sure that you change your comments as this method has changed. And again, we'll keep same initial value, or you can change the initial value, but in this case we will change, because we don't have f beam prime. So we will define a new function called dx, or a new variable called delta or dx, and let's call this 0.5. So which we're saying that take the value of the function at 300 at 300.5 and use these 2 points, which is a secant, which form a secant, to calculate the slope or the derivative at that point. So this will become dx multiplied by the value of the function, and then divided by, here we have a difference, we will have a difference between the value of the function at x0 plus dx minus the value of the function at x0. So this is basically replacing the derivative. And again, everything else is set. We save it and we run it, and we can see again in the third iteration we got almost the same, exactly the same answer that we got for Newton-Raphson method. This concludes secant method.